Welcome to this first lesson of C6, the Introduction to Electrolysis. In this lesson, we're going to look at what electrolysis is and work out what the products of electrolysis would be. We're also going to explain why only certain substances or substances in certain forms can be electrolyzed. So what is electrolysis? We can get the meaning of this word from the word itself. Electro meaning electrical current and lysis meaning to split something up. So electrolysis is using an electric current to break down an ionic compound. That ionic compound we refer to as the electrolyte. That's just the thing that's being broken down. The setup for electrolysis is shown in this diagram. You can see we have a beaker of the ionic solution, and in that beaker there are two electrodes, a positive and a negative electrode, connected to a power supply at the top. There are a few key words that you'll need to know and be able to label on this diagram. The negative electrode is called the cathode, and the positive electrode is called the anode. The electrolyte solution will contain positive and negative ions. Those positive ions are referred to as cations because they're attracted to the cathode, and the negative ions are called anions. They're attracted to the positive electrode. Have a think about this question over on the left. The electrodes are made of an inert material, so unreactive. Some examples are graphite and platinum. Why would it need to be made of something inert? If you were thinking that otherwise it would react with something in the electrolyte solution, or maybe the products of electrolysis itself, you're absolutely right. Only certain substances can be electrolyzed. The substance is ionic because we need the positive and the negative ions to be able to be attracted to the positive and negative electrodes. That ionic substance has to be either molten, melted, or aqueous, which means dissolved in water. If it's solid, if you look at this top diagram here, all of the ions that are part of that ionic substance have really strong bonds between them. They're fixed in that ionic lattice. Those ions cannot move. However, if you melt the substance or you dissolve it in water, those bonds between the positive and negative ions are disrupted, and so the ions are free to move and they can conduct electricity and complete the circuit. So in electrolysis, if your substance is solid, your electrolyte is a solid, nothing will happen, it won't work. If it's molten or aqueous, remember that's just dissolved in water, then the electrolysis can happen and the ions can move. If we think now about what products we'll make, obviously the products that are made depend on the ionic substance that you start with. However, negative ions will always be attracted to the positive electrode and positive ions will always be attracted to the negative electrode, so opposites attract. In this diagram you can see we're electrolyzing molten zinc chloride. So this is zinc chloride that's been melted. We have zinc ions which are positive and we have chloride ions which are negative. The zinc ions, because they're positive, will move to the negative electrode, where zinc metal is formed. The chloride ions, because they're negative, will move to the positive electrode, where chlorine gas is formed. We'll look in a future lesson about how those changes happen at the electrodes. What products would you expect to be formed during the electrolysis of molten lead bromide? Have a think about those for just a minute. If you said that you would get lead at the negative electrode and bromine at the positive electrode, you're absolutely right. A common mistake here is to write that bromide is formed. Remember, bromide is the ion and bromine is the atom or the element. So what we're going to do now we've got a bit of that knowledge, is we're going to go through some exam style questions. What I would suggest is that every time a new question comes up, you pause the video, write down your answer, and then play the video again and I'll explain the answer to you. So question 1. One of the products of the electrolysis of molten magnesium chloride is magnesium. Name the other product. If you said the other product was chlorine, well done. If you wrote chloride, that wouldn't get you the mark because chloride is the ion, chlorine is the element. Second question, use the correct answer from the box to complete the sentence. Solid potassium chloride does not conduct electricity because the ions. And the correct answer is cannot move. The size of the ion doesn't affect electrolysis, and of course we know that potassium ions would have a positive charge and chloride ions would have a negative charge. So it must be that middle answer, they cannot move. Sodium chloride solution contains sodium ions and chloride ions. Sodium chloride solution is electrolyzed. Explain why the sodium ions are attracted to the negative electrode. The answer is because they're positively charged. They've given you the formula for the sodium ion in the question up here, Na+. So they're positively charged and opposite charges attract. This one has given you quite a complicated looking diagram. You'll notice that the electrolysis cell in this example doesn't look like the ones that we've seen before. The ones we've seen before have a beaker with a positive and negative electrode dipped into them. This one has the negative electrode as the container and a positive electrode dipped into it. So it's a slightly different arrangement, but the theory is exactly the same. So the question is, name a gas produced at the positive electrode. The answer to that question is oxygen. You can see there are oxide ions, O2-, in the molten mixture, and those oxide ions will move to the positive electrode because they're negative, and when they're there, they will form oxygen gas. Name the particles which carry the electric current through, firstly, the metal wires, and secondly, the solution. The answer to part 1, the particles that carry the electric current through the metal wires, is electrons. In metals, it's electrons that carry the electric current. In part 2, in the solution, it's ions. Those positive and negative ions that we saw in our setup are carrying the electric current. Explain the meaning of electrolysis. They've given you 4 lines to write on here. You don't need to write a huge amount, it's only 2 marks. And the answer is splitting up an ionic compound using an electrical current. 1 mark for each of those 2 parts. Okay, that is the end of today's lesson, and that takes us through the things that we looked at the beginning. What electrolysis means, what the products of electrolysis would be and how we can predict those, and why only certain substances, i.e. molten or aqueous substances, can be electrolyzed.